This is a video for AQA Mechanics, Center of Mass and Moments, section 2.2, which looks at some problems involving ladders. Well, a ladder is simply a rigid body which would be in contact with two surfaces which are often at right angles to each other, for example a wall and the ground. The weight of the ladder would be at some point, if it's uniform, obviously at its center. However, that may well be different depending on the question. Then there are forces at the contact points. At the floor there will be a reaction force and possibly a frictional force. So let's call those R1 and F1. And at the wall a reaction force which is normal to the wall, and again possibly a frictional force. I say possibly because it depends whether the surfaces are rough or smooth. Now, to find unknown quantities in any given question, we can use the usual methods of taking moments about any point and then looking at the forces in two directions. Often these will be vertically and horizontally. The other added part to these questions would be that because we've got friction, then we would use the fact that the frictional force in its limiting situation F is equal to mu r, where mu is the coefficient of friction. So let's look at a couple of examples to illustrate these points then. Here we've got a uniform ladder which we're told is 8 meters long. So the fact that it's uniform would mean that its weight would be acting at the center point, i.e. 4 meters along the ladder. We're also told that it's on the point of slipping when the base is 4 meters from the wall. Now we can use a little bit of geometry, trigonometry to work out things, and if that's 8 and 4 we can use Pythagoras' theorem to show that the distance up the wall is 4 root 3 meters. Alternatively, if you wanted to use this angle here, then theta is cos to the minus 1 of 4 over 8. That means that theta is 60 degrees. We're told that it's against a smooth wall. That means that there's only a reaction here. Let's call that one R2. But there's a frictional force at the ground, so we've got a normal reaction R1 and a frictional force here F. And because it's on the point of slipping, we can say that F there must be equal to mu multiplied by R. So this is our force diagram, and we're asked to find the value of mu for this particular situation. The first thing we can do then is resolve our forces vertically, and we can see that we've only got two forces which have got any components vertically. One is R1, which is acting upwards, and that must be equal to mg, which is acting vertically downwards. Secondly, we need to take moments about some point. Now we don't know R2 and don't need to find it, so the easiest point is to use this point here. Let's call it B. If we call the ladder AB, then taking moments about B, then we can see that we have got in the anti-clockwise direction F produces a moment, and the distance of F from B, the perpendicular distance, is 4 root 3 from the work we did earlier, so that we have F multiplied by 4 root 3. The other thing which is acting in an anti-clockwise direction is mg. Because mg is acting at the center, we know that this is at a distance 2 perpendicularly from B. So F multiplied by 4 root 3 and then 2 mg. Those are the anti-clockwise moments, and they must be equal to the clockwise moment, which is R multiplied by 4. And we know that R is mg, sorry, R1, I should have said R1 multiplied by 4, so that's equal to 4 mg. Rearranging that then gives that F must be equal to 4 mg minus 2 mg, so that's 2 mg, and then divided by 4 root 3. Once we've got F, we can say that mu must be equal to F over R, because we've got a limiting situation, and therefore mu is equal to 2 mg divided by mg, so it's just, 2 mg over 4 root 3 divided by mg, and therefore it's 2 over 4 root 3, which is equal to root 3 over 6, or as a decimal 0.289. In this second question, the ladder again 8 meters long and initially 4 meters from the wall, so that we have the same situation where this is 8, 4 and 4 root 3, and the angle here is 60 degrees. We're told this time that the weight is 250 newtons, again uniform, so that 250 is acting at the center point here, 250 newtons, and we've got the rough ground, so frictional force and reaction here, but this time the frictional force is given by a coefficient of friction of 0.4. We're then told that a man of weight 700 newtons climbs up the ladder to some position here, so it's resting at this point 700 newtons, and the question is asking us how far up can he climb before the ladder starts to slip, so we're on the point of slipping. So this is the force diagram this time, and so first of all, resolving vertically, we can see that R1 must be equal to 700 plus 250, so R1 is equal to 950 newtons. We know we've got limiting friction, and therefore F must be equal to mu R1, which means that F is equal to 0.4 multiplied by 950, which is equal to 380 newtons. Now we can take moments. It's best again to take moments about point B at the top of the ladder, because we don't know R2 and don't need to know R2, and therefore if you take moments about that point we can ignore R2. And because I want to take moments about that point, I'm going to look at the distance of the man from B, although the question does ask us to say how far up the ladder he climbs, so therefore we're going to have to consider that in a second. Right, so taking moments then. We have got three forces, the frictional force, 250 and 700, all of which are anti-clockwise moments. So firstly, the frictional force, which is 380, and its distance from B is 4 root 3. So remember the geometry that we did earlier gave that distance there as being 4 root 3. The 250 Newton force is at a distance of 2. It's halfway up the ladder, and the ladder was 4 meters from the wall, so that will be a distance of 2 from B perpendicularly. And then we've got this 700 for 700, and then we need the distance from B. So that will be y multiplied by the cosine of the angle at the top here, which is 60 degrees, using alternate angles. So it's y cosine of 60 degrees. So those are the anti-clockwise moments. The clockwise moment is provided by just r1, which we know is 950, and its distance from B is equal to 4. So we get 950 multiplied by 4. Now if we rearrange that, we can see that 700 y cos 60 must be equal to 950 multiplied by 4 and then minus these two values. So that is equal to 3,800, which is 4 multiplied by 950, minus 500, and then minus 4 times 380 is 1,520 root 3. So if you then calculate that and divide by 700 cos 60, you find that y is equal to 1.91 meters. And therefore we can say the answer to the question, the distance up the ladder is equal to 8 minus 1.91, and that's equal to 6.09 meters. Well, that's the end of this video about ladders, and in the next video we'll be looking at objects which are suspended.